Displacement time graph. Objectives: to determine the average velocity of a trolley traveling down a ramp, to determine the acceleration of a trolley rolling down a ramp from its displacement time graph. The first graph is the displacement time. In that graph, we can find the velocity, the values of instantaneous velocity at A and at B. So at A, we draw the tangent, and we find the gradient at A. We find the gradient at B. The gradient at A represents the instantaneous velocity at A, and the gradient at B represents the instantaneous velocity at B. Then the acceleration equals the final velocity minus the initial velocity over the difference between the time, TB minus TA. Apparatus, trolley, runway, two light gates, data logger. First, I will set the runway to be 5 centimeters above the table, exactly 100. So this is at 100. So I sit here at exactly 100. So this will be the fixed position. The first trial, I will fix the second light gate after 10 centimeters. So now I fixed the second light gate after 10 centimeters from the first light gate. This is the trolley. Every time I will start at the same position. Let here the position is 102. The front of the car is at 102. This I started to connect the data logger to the computer. Now I use the program. Easy. I take timing and then next from gate A to B. Next, I take 2 decimal places and the time in second. Finish. The first trial, exactly I put the car, the trolley, at 102. And then I release it. So do not push, just I release it to move freely. So the first time, 0.37 when the distance is 10 centimeters. The second trial, I will fix the gate, the second gate, after 30 centimeters. I put the trolley at the same position, 102 centimeters, and I release it to move freely under gravity. This is the second trial. When the distance is 0.3 meter or 30 centimeters, the time is 0.99 seconds. The third, I will fix the second gate at 50 centimeters. Release it. The time is 1.35 seconds. And I leave the trolley to move freely off ramp. Yes, I measure the time. The time is 1.74 seconds. Last trial when the distance is 90. And release it to move freely. We draw the graph, displacement time graph. That are the points. Now we draw a curve passes in between the most of the points. It is a curve. Then we draw that curve. So this is the curve that represents the displacement time graph. Describe the motion because it is not a straight line, so it is non-uniform velocity. Calculate the average velocity of the trolley. Now to calculate the average velocity, we draw a triangle. Slope from this triangle, the slope or the gradient equals. We calculate the slope or the gradient. The answer is 0.44. This is the slope. So the velocity equals 0.44 meter per second. We can take this point as point A and this point as point B. We draw the tangent at the point A to find the gradient or the slope at the point A. So this is the tangent, and we draw, of course, triangle to find its slope. We find the slope at the point A. So V at A, we find the instantaneous velocity at A. It is 0.38 meter per second. The same way we find the gradient at, we find the instantaneous velocity at B. Velocity at B is 1.15 meter per second. Now we find the time at the point A. So this is the point A. T at A, the time at the point A is 1.0 second. We find the time at the point B is here at the middle. It's 1.7 second. Then the average velocity, the average acceleration is V at B minus V at A over T at B minus T at A. V at B is 1.15 minus V at A 0.38 over T at B 1.7 minus 1.0. We find the acceleration. The acceleration is 1.10 meter per second squared. I hope you understand this experiment. Thank you.